Okay, so so what we have here is the test bed for testing the printed OECTs. Let's show the printed OECT just in. Yeah. Okay, so these see-through little devices are actually the printed OECTs that we will be showcasing today. They came from Rice. Thank you, Peter. Okay, here you go. And here is the test bed that contains all the necessary electronics for switching the OECT. And this is the, let's say, development kit for the stimulation, because we need to have it all in one place, both stimulation and control of OECTs, so that we can push. This is a single channel stimulator. This single channel through 4 different channels. These devices here are actually 2 to 4 decoders, which would mean that basically with 2 different control signals, you can select on which of 4 different channels you want to pass the stimulation signal that will be produced by this device here. So we have made a little app that can control this. So maybe now we can play the number 1. So we will put it on the first channel, just so that we would allow everything to function properly. After the command, there is like a 10 seconds difference or 10 seconds pause that allows the system to set up, and then the stimulation is passed. And you can see here, hopefully you can see here on the first channel. Okay, I will actually now zoom in this very high-tech way. So now we will play the which channel? Second channel. Okay, so we are expecting it to turn on in the green. Okay, so now we are playing the stimulation on the second channel, all through the printed OECT circuit. And here we already have a current. Play the third one right away. Here we have a current that is strong enough to actually elicit stimulation that can be sensed. So this is above the sensory threshold, so already something that has real application. Now you can see the blue signal showing the pulse, and you can see that on the other 3 channels the pulses are very, very small, so almost non-existent, definitely below the threshold of anything that is noticeable by a human being. And now we have it in the final channel. And okay, so this was the first part of the demo. Okay, sorry, I will reset our camera. So now we have the second part. This was all done in traditional electronics. And now we have a different human model equivalent circuit, which was produced between by BC Materials in collaboration with us. So this is fully printed version of the wait, where is the other circuit? Yeah, okay. So this is a fully printed version of basically this circuit. Well, actually, it does a bit more. And this is a circuit that behaves in a way that is similar to a human being when connected to the electrical current. So it has resistive and capacitive components. And basically, when we pass signals while connected to this device, the entire system behaves in a very similar way to how it would behave when connected to a human being. Well, this one actually was modeled by one of us. We won't say which one, but I think that it is quite obvious which one of us this represents, right? You saw it from the picture from the elevator. Now, the thing here is that this will allow us to actually test all these printed electronics in the relevant environment, but without actually using human subjects. So this was the main purpose, and also this is built in the same processes, by the same process that are used for printing the OECT devices. So this actually allows us to have practically an OECT devices made together with these human model equivalent circuits in every batch, so that we can really test if all the things printed work properly, work as expected, and then we can use them on humans, which is quite important from the safety perspective when working with well, systems that exchange energy with humans. So yeah, Vlada, if you can connect this, and now we have a slightly different setup, so that we can observe the signals when they pass through the human model equivalent circuit, printed human model equivalent circuit. Okay. Yeah. So, okay, now the signal will be playing. So I will go here. We are looking at the violet, I guess that's the color, or magenta signal. Okay, so we need now to do a bit of a setup with the oscilloscope. Okay, yeah, we connected wrong wires. So I will be talking a bit more while we reset which wire actually should be connected, but this is what happens with live demos. All in all, the signal that we will see eventually will be exactly the same as the one. Okay, so now we try again. So the magenta signal should be the same as the signals. Okay, yeah, so the magenta signal looks just as expected. It is a compensated square. Okay, we will play it again. And also we see some other signals that that are relevant for our research, because with this human model equivalent circuit made by biomaterials, we actually have capability of measuring signals at every single point, so we can see if really everything works as expected. So there are some important features for us, like what is the capacitance, how fast do they charge, and what is the transient time, and so on. So more or less, this is what we have for the demo part. But now we would like to show how these things are really fully integrated. So here what we can see is the full Wearplex electrode with these 2x4 decoders. But also what was done in the beta part is that they were all printed on the same substrate. So you can see here we have 4 pads and decoders printed on the other side. Yeah, I don't know if you can see that well. Okay, now here. Okay, so you can see decoders printed on the same substrate as this, and this can all be ran by the stimulator made by Technalia, but this will actually be presented in the next presentation by our colleague Pierre. So that would be that from our side. Thank you.